Okay, in this video I'm going to solve problem number 8 as shown here. And problem number 8 deals with these 5 permutations at the top from problem number 7. And I'm composing permutations. So what I'm going to do is for part A, I'm going to write it out in kind of a longhand. I'm going to say that P2 composed with P4. So first of all, we kind of go backwards, kind of like function composition. These are bijections. Permutations are bijections, so they're also functions. P4 applies first, and then we apply P2. Okay, and so P4 takes 1, 2, 3, and 4. Oops. And 5, and maps them to P4 goes 5, 2, 3, 4, 1. This is P4. And here's P2, again written in longhand notation. P2 is 2, 4, 3, 1, 5. And so P2 composed with P4 is taking 1, 2, 5. Why? 1 went to 5, then 5 went to 5. 2 goes to 2, then 2 goes to 4. Where does 3 go? Well, 3 goes to 3, and 3 goes to 3. So 3 goes to 3. 4 goes to 4, and 4 then goes to 1. Finally, 5 goes to 1, and 1 goes to 2. And we better have a permutation at the bottom here, and we do. Okay, 5, 4, 3, 1, 2. So there's the composition of P2 and P4. Next I'm going to compose P3 with itself. And I'm going to copy down P3 here. I'll try to cordon off my space. P3 is the permutation 3, 2, 4, 5, 1. And so P3 composed with P3 is, well, 1 goes to 3 and 3 goes to 4. So 1 goes to 4. 2 goes to 2 and it stays at 2. 3 goes to 4, but then 4 takes us to 5. 4 takes us to 5, but 5 takes us to 1. And 5 goes to 1, which is 3. Okay, so there's P3 composed with itself. And again, we double check by making sure all 5 of these numbers are different in the bottom, because the composition of 2 permutations better be another permutation, which means it's a bijection, 1 to 1 and on to, and we've got all 5 different numbers here. Part C, compose P3 with P5. Okay. And I'm going to apply P5 first. 1, 2, 3, 4, 5. And then I'm going to apply P3. And P5 is 5, 4, 3, 2, 1. And P3 is this, I have it right here, 3, 2, 4, 5, 1. And so P3 composed with P5, applying P5 first, 1 goes to 5, 5 back to 1. So 1 goes to 1. 2 goes to 4 and then to 5. 3 goes to 3 and then to 4. 4 goes to 2, which stays at 2, and 5 goes to 1, which goes to 3. Okay, so there's 3 composed with 5. And we can write this back in standard notation, 1, 5, 4, 2, 3. Or we could write it in cyclic notation if we wanted to. 1 goes to 1, so it's a fixed point. 2 goes to 5, which goes to 3, which goes to 4, which goes back to 2. So there's cyclic notation. Okay? I'll put a little C there for that. Okay, let's see. Let's finish this up. Part D is P4 composed with P4. So P4 is 1, 2, 3, 4, 5. P4 is the pattern. 5, 2, 3, 4, 1. 5, 2, 3, 4, 1. And so, P4 composed with P4, we're just going to apply P4 twice. It takes 1 to 5 and then 5 to 1. It takes 2 to 2 and then 2 to 2. It takes 3 to 3 and leaves it fixed. 4 is fixed. 5 to 1, then 1 to 5. Hey, P4 composed with itself is the identity element, or the identity permutation. Leaves everybody fixed. Okay? And so that's problem 8 here. Permutation composition. Hope that helps.